Welcome to section R.1 and R.2. This is your support class, and we're going to go over questions that are similar to those that's going to appear on the exam. So pay close attention to these questions. Let U be the universal set 1, 2, 3, 4, 5, 6, 7. S equals the set 2, 3, 4, 5. And T equals 2, 4, 6, 7. List the elements of the following sets. S prime intersect T. Definitely pause the video and try these questions on your own. I will ask you to submit these notes for your points. When I see these types of problems, I always do the complement first. So we'll look for S prime, and in order to find S prime, we have to look for S. Now, S prime is going to be everything that is not in S. 2, 3, 4, 5 is S. So the complement, or the opposite of S, would be 1, 6, and 7. 1, 6, and 7 is S prime. Now for the first part of the question, we're looking for S prime, which we found. Now we'll have to intersect that with T. S prime intersect T is equal to 1, 6, 7. Intersect that with the set T, and here's the set T. The set T is 2, 4, 6, 7. Now remember, the intersection is what is common in both, or the overlaps. For the intersection, we're looking for the overlap of the two different sets. So what is common in both? In this case, we have they both share a 6. They both share a 7. So S prime intersect T is equivalent to 6 and 7. For question 2, we'll let the universal set be the numbers from 0 all the way to 14, the whole numbers from 0 to 14. A is the set 0 to 4. B is the set 0 to 4, 6. C is the whole numbers from 0 to 6. We'll use A, B, and C to find the following. A prime union B, and then intersect that with C. I always like to do the complements first, so let's find A prime, or A complement. A is 0, 2, and 4. So we'll look in our universal set. And A complement is everything except 0, 2, 4 in the universe. So we're looking at 1, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So A prime is equivalent to 1, 3, 5, and we're going to write all the numbers up till 14. And so this is A prime, 1, 3, 5, and then 6 all the way to 14. Now let's try to find A prime union B intersect C. We know this is A prime, so I'll fill that in here. 1, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We'll union that with B, which is 0, 2, 4, 6. And we'll put a parentheses around that because we have to do that first. And then finally, we'll intersect that with C. And C is 0, 1, 2, 3, 4, 5, 6. Now the union is what is in one or the other or both. So I'm going to list all of the elements in both of the sets. We have 0, so we'll write 0, 1, 2, 3, 4, 5. So essentially we have all of the numbers, the whole numbers from 0 all the way to 14. We're going to intersect that with 0, 1, 2, 3, 4, 5, 6. And now remember, the intersection is the overlaps again. So we're going to have that they both share a 0, a 1, 2, 3, 4, 5, and 6. So they both share 0, 1, 2, 3, 4, 5, 6. So finally, our intersection between these two sets is just 0, 1, 2, 3, 4, 5, 6. So for these types of problems, take it slow, write out everything, and then determine the unions and intersections, but always start with the complements first. Evaluate the expression. We have negative 5 times the quantity 10 minus 9 plus negative 7 times 2 squared. I always look for the parentheses first, and in this case we do have parentheses, the 10 minus 9. So we'll do that first. 10 minus 9 is 1. And I like to leave everything else alone until we finish the problem. So we'll do one step at a time. Next, there are no parentheses. This is a multiplication, this is a multiplication, this is an exponent. So there are no parentheses, but there is an exponent. This 2 squared should be done next. We have negative 5 times 1 plus negative 7 times 4. There are no more exponents. We'll move on to multiplication or division, again from left to right. In this case, I'm going to do multiplication from left to right, so we'll do negative 5 times 1, and we'll also do negative 7 times 4. We have negative 5 minus 28. Let's add these two together. We get negative 32. We get negative 32. This question gets a lot of people because of those fractions. So let's focus on fractions. I'm going to use my orders of operation and write down PEMDAS so I know which one to do first. There are parentheses, so we always go to the innermost one first. This one's innermost, and this one is also innermost. So we'll go from left to right since there's two sets of parentheses. For the first one, I need to find common denominators. Now I need to make the denominators on the bottom the same. So I'm going to multiply the bottom here by 4 and the top by 4. Now the reason you do this is to get the same denominator, and I can multiply the top and bottom by 4 because that has a value of 1. It doesn't change our expression. I'm going to multiply the top and bottom by 7 here. Again, it's okay to do because this has a value of 1. It doesn't change the value of 1/4. Now, this causes the denominator to be both 28, and that's what I want. We're going to subtract negative 6 over 14. There is a double negative here, so we're going to change that to a plus 1/2. Let's simplify the left side. We have negative 1 times 4, that's negative 4. 7 times 4 is 28. 1 times 7 is 7 over 28 again. And notice we do have the same denominator. You cannot add or subtract fractions unless they have the same denominator. Very important. Negative 4 minus 7 is negative 11 over 28 minus negative 6 over 14 plus 1/2. Now we still have parentheses. This is still considered a parentheses, so we'll have to do that first. I need to get common denominators, so let's multiply the top and bottom by 7, and that will give me a 14 on the bottom. So you'll just have to think, do you need to multiply one side or both sides to get the same denominator? So now we have negative 11 over 28 minus negative 6 over 14 plus 7 over 14. We have negative 11 over 28 minus, now we still have to simplify this, so this simplifies to 1 over 14. I don't need the parentheses anymore. This is a subtraction. So we'll need common denominators again. Let's multiply the top and bottom by 2, and that's going to make it a denominator of 28. This gives me 11 over 28 minus 2 over 28, and this reduces to negative 13 over 28, and that's our solution. So we had to do a lot of work with fractions and orders of operations. We want to use the orders of operation, remember that's PEMDAS, to do this question. We always start from the top first and we'll work on the bottom. For the top, are there any parentheses? Absolutely no parentheses. This is a multiplication. This is not a parentheses. Then I'll look for exponents. There is no exponents on the top. Is there multiplication or division from left to right? Again, we do it in order from left to right. We're going to do the multiplication first. The negative 2 times negative 6. So we'll multiply negative 2 times negative 6 first, and that's going to give us a plus 12. Now the bottom is 10 minus a negative 6. We'll have to do the division next. 12 divided by 12 is 1. And the top now simplifies to negative 7 plus 1, which is just negative 6 divided by 10 minus a negative 6. Now don't feel tempted to cancel out 6 and 6 here. You cannot do it because of the negative sign between. You can't do it. If this was multiplication, you could, but you can't do it across a subtraction or addition symbol here. We'll simplify the bottom first. We have a double negative. I'm going to change that to a plus 6. So negative 6 over 16. And notice there's a common factor of 2. So we'll reduce that by 2. I get negative 3 over 8 is our solution. Let's evaluate x equals negative 4 and y equals 1 for the following expression. What that means is we're going to do some substitution. We'll replace the y with 1, and we'll replace all of the x's with a negative 4. We'll simplify the top first. I have negative 1 I have negative 8 times 1. That simplifies to negative 8. And this plus negative 4 is equivalent to just negative 4. That gives me negative 12 in absolute values, and I'm going to divide that by negative absolute value of negative 4. Now remember, the absolute value is going to change my number to a positive number, so the top is 12. And now I can simplify the bottom. The absolute value of negative 4 is positive 4, but the negative's in front, so we're going to have to keep it. This is 12 over negative 4, and that simplifies to just negative 3. So our solution is just negative 3.